Ich höre irgendwie nichts. Ich höre nichts. Mute.
Oh, now you should hear me.
Ah, sounds better.
Sounds feel better. Yeah, super. Sorry, mixing German and English.
Sure.
So, a bit about us. So, not really working. Oh, here. So, Vienna Data Science Group. Who is new? First time. Don't be shy. Amazing. Oh, yeah. Also, my colleague Philip is new. So, we'll do, first agenda. So it will be brief introduction of Vienna Data Science Group, who we are, what we do, what we propose, what we offer, why we are cool. Then there will be a presentation from Crayon, who nicely host us today. We should really give a big shout to them. Then we jump to the main talks and open mic. So if you have any announcement to do, or you want to come to a stage to announce something, opening job positions, PhD positions, whatever announcement that you can come later on. And when we finish, we have a socialize event. So we have some pizza and drinks and chats. This is important. So, Vienna Data Science Group. So we are a non-profit association, and our goal, main mission, is to create a community. So to bring people together in the field of AI, not necessarily working in the AI and data science field, but being enthusiastic about this field, so being curious. And why bringing people together? Because it's important so people can connect, exchange ideas, create teams, also hang out. So, but we also promote the knowledge through, for example, the meetups, educate people, and it's a vision that we have been having in the past 10 years. A bit who is behind the events. These are some faces, so you can also connect people to faces. Here tonight, it's going to be me and Georg. If you have any questions or you want to present or you want to start even an activity with us, please don't be shy. You can approach us at any time or you can write us. But if you talk face to face, it's always nice. So we also know you. The events at the moment, we are running 2 main events, the Meetup, so will be mainly knowledge feed. We invite speakers to present the cutting edge solutions, technology, what they are developing. We ask actually to not present, to sell products. They can present their product, but not to sell it. This is not what we want. And we have a data science cafe that was run by our colleague Mari at We Accelerate. It's a more informal event, but really cozy, and it's really important for networking, shared mentors, assisting people with questions, or even guiding on specific topic. We will run it this year. It's over, but we will run it from next one. Next event. So we are going to have, you can already sign it in your agenda, 29th of January. We're going to have an event at Arsenal, TU Wien, co-organized with Vienna Scientific Cluster, and will be also a guide tour of a Vienna Scientific Cluster facilities. It's not announced yet, official, but you know that is going to happen. So we don't only organize events, but we also publish, and we publish books. Amazing, in the area of articles online and ebooks. We publish the Handbook of Data Science and AI, and we already have a second edition. It's in German and English. You can find it at Italia or online. So. So today, as I said, Crayon nicely host and sponsor the event. So please let's say thank you to organizing Daniela, Daniel, and the presenters. Here are some sponsors. And if you also want, you can become a Vienna Data Science Group member. There is a membership, not really expensive. It helps us to organize events and to keep up with the cost. So if you want to join, please, we are really happy. So you can follow us emails or LinkedIn. We don't have really social media, and Slack. This is our main channel of communications with LinkedIn. So now I can leave the floor to Crayon, to Said, to present.
Yeah, sure.
Thank you.
So thank you for this nice introduction, and thanks everybody, the Meetup group, the Vienna Data Science group. And I have a question. I hope that data scientists are not the only ones who are attending. And I know that there was a migration over the time from data scientists to engineers. So I hope that you are covering a bigger target group and not only data scientists. And I know the data science itself cannot work. So most of the data scientists we have here, they have engineering knowledge, platform knowledge, cloud knowledge, and many other knowledges that are really useful. But I really would like to welcome all of you, the organization that organized it, and also the Meetup team. And Cryon, I don't know if you know about Cryon. It initially was a software asset management and licensing company established 20 years ago in Norway, but Center of Excellence, part of it in Vienna, came to appearance 5 years ago. So we are very interested in different AI domains. We have platforms, engineering, computer vision, language technologies, decision intelligence, multiple groups. And it's an honor to have all these people that are interested in the topic of AI. And hopefully today we will share and learn from each other in this domain, and would have a good networking session all together. Thank you all. That's a short intro from my side, and we can move on to other session. Any question from anybody or any concern? Want to know more about our goals or Cryon? I'm here and I can answer the questions. Thank you.
Thank you. I need your PowerPoint. It's in Chrome. Oh, here. Okay. Okay, super. So now we can you use one on stage. So they both work at Cryon. One of these machine learning engineering, working machine learning ML DevOps, bringing into production machine learning product. While Julius is a neuroscientist, nicely found out, who founded a company in tech fitness, and now is working in Cryon as a machine learning and visualization. Computer vision. So leave the floor.
Yeah, I mean, let's keep it simple. I'm right now a machine learning engineer, intern at Cryon, and I'm working together with Muhammad, and we are going to lead you through some topics regarding GenAI for images. So maybe first of all, we want to tell you how it works exactly, then lead you through some recent research and improvements that have been made over time. And then even Muhammad is going to give you tips and tricks on how to deploy your own models. So without further ado, let's start.
So from the topic Gen for images, first, what is GenAI? Click correctly. Yeah. Doesn't show.
You need to click.
So GenAI stand offline. I think we need to click so to show automatically.
One light, I think it's Also, okay, I don't think the video is required online.
Yeah. So GenAI stands for Generative Artificial Intelligence. It's a new type of AI that can create new content. It can create text, images, video, and audio. Today, our focus will be more on the genetic images. Let's start with the image generating model family. So the last 10 or 15 years, many models have been published and created by to generate different images. Some of them they were famous. Some of them nobody cared about them. But the most famous model one is the variational autoencoder. The idea of it, like you encode and compress the image into small and latent space. Then you decode it back to the original image, and by this you can also learn the distribution of the data. Another model is the autoregressive model. It's a little bit working in a different way. It's working on pixel by pixel, so generate an image by pixel and working with them as a set of sequence. This get more attention in the language model, in large language model, and is used more in that field. Another very famous model is the generative adversarial network, GAN. It works as you have two models working against each other. One is called the generator, which is create an image, and the other one is the discriminator. It decide if the image is real or not. And this one is teaching the other, and the first one teaching the second one. Those models were okay the last, let's say, 5 years, but suddenly, like 3-4 years ago, a very famous model came on the domain, which is the diffusion model. The first paper of the diffusion model came on 2015. Nobody really cared about it. We believe mainly because of the computation power. 5-6 years ago, we didn't have really that powerful GPU or wasn't accessible for everybody. But now we can see in the cloud provider, they can provide you many powerful GPU and you can access it very easily. So the last 3-4 years, it gets very high attention. And the results, as you see, between 2014, when that was very pixel, the generated image, end of the 20s, they start to get some good result, but it's very blurry. And now we can see very realistic image. It's very hard to distinguish between the real one and the fake one. And many company, also the famous company, has used the fusion model in their production. The fusion model can also categorize in 2 different types. One is the unconditioned diffusion model. So the image is generated from random noise without any guidance, without any input. This is useful usually when you want to, for example, generate an art or some static data. So you just train on some images and it will generate some new image. You don't have control over that. Also useful if you want to create a high resolution image also. The other one is the conditional diffusion model. Here you have a guidance to know what output you want. You can have a text, for example, picture of cat, and it will generate you picture of cat. Also, you have image in painting. You have an image and missing some part, and it will fill those missing parts in very robust way. So the more interesting question, how it works. The idea is very interesting. It comes actually from physics. You have a random noise image, and from this image story, you are removing the noise until you get a generated image. But how can that be done? You have first the first step is called the forward diffusion. So you get set of image, you get the image, and gradually adding some random Gaussian, it's called Gaussian or random noise to the image, slowly until we get a fully or a pure noise image. Now at each step from this, adding the noise, we train a model or neural network to learn to remove this noise. So we are at step 1. We try to learn how we can remove this noise to get the original image. In the step 2, we try to learn how we remove this noise to get to the image, the second image, and so on. After that, we can use the model. We give a random noise, and the model will try to predict step by step till you generate a new image. Again, this one is unconditional. So you have a random based on the noise that you have, or the noise image that you have. It will generate specific image. But now Julius will explain more about how we can have condition and how we can have different method or improvement to get the better result.
Let's switch places.
Yeah.
Let's do it like this. And I also saw that this annoys me a bit. Okay.
I was getting distracted.
Okay, so Muhammad led us through how these models approximately work. And over the last 1.5 or 2 years, a lot has changed. Lots of improvements have been made in this area. And I thought about, like, what exactly can I even talk about? Like, it's so much. Muhammad showed you the graph on diffusion modeling research, published research on this. This has even like exploded this year a lot more. And I picked a few architectural milestones that I deem to be worthy to talk about today. So let's get into it. The first one is the diffusion transformer. I'm assuming that most of you know what a transformer is. For those of you who don't or have never heard of this, I don't think that's the case, but let's just assume maybe. So the transformer architecture is the backbone of the recent revolution in GenAI. So everything like from ChatGPT or other LLMs is based on it, and now is also being used in any other field of AI. For example, let's say AlphaFold by Google is using it, and now vision and diffusion models also try to incorporate this. So on a very basic level, in language, the transformer architecture uses its attention mechanism to make words in a sentence attend to each other, try to find other words that it finds especially interesting, and then can predict new words on this basis. In vision and diffusion transformers, so first of all, this is a highly scalable architecture, which is great because we can just throw GPUs at it and it will perform better. So in diffusion transformers, the goal is not to predict the next image, but a denoising step, so to say. So what we do in diffusion modeling, we split an image into patches. That's what you can see here. We patchify an image, give numerical representations to all those patches, and then the patches attend to each other again. They try to find other patches they find especially interesting, and on this basis, new denoising steps can be predicted. Also, the diffusion transformer gets a so-called time step embedding, which is also an input to the transformer block, if you will, which gives the model information on which time step it is at the moment. Like Moana told you, this diffusion process happens in steps, and this time step information gives like the model a piece of information to work with to better predict noise. This, by the way, substituted a technology or an architecture called the UNet, and the UNet was based on convolutional layers, and this was used before. It's still used, but I've got to say that in recent research, I've only seen diffusion transformers being used. Yeah, as I said, substitution. And VIT's vision transformers were the first vision models where transformers were used, like diffusion transformers. That's rather new or rather recent. Let's move on to the second milestone, control nets. One thing that all GenAI models have in common, they have a problem with control. The best thing I could imagine, I want to imagine some sort of image in my head. I want to translate it into text, into a text prompt. And this text prompt I want to feed into a diffusion model. And the diffusion model should return some image that is very close to what I imagined in my head. But this is not reality, obviously. And not only because we are not quite there yet, but also because control over the content is difficult to achieve. So this control net architecture, or basically building block, was proposed 2023. And this is essentially a building block that comes before the diffusion model, which feeds some sort of input into the diffusion model. So the diffusion model has something to work with. You could imagine this is something like giving an art student reference material or some guidelines, so that the art student still has the artistic freedom of, for example, filling lines or filling a depth map or filling like a human pose or a segmentation map. But still, we have to give the art students some sort of reference material. If you just tell them draw something, they're going to think you're mad, right? So this control net, as I said, gives a reference, and it allows the precision that we need for diffusion models to create something. So we're getting closer and closer to this point where whatever I'm imagining in my head can actually be produced. But also, I mean, this should be obvious, but you need to be able to translate your thoughts into text yourself. I'm sorry for that. Thirdly, I want to talk about flow matching. This is a fascinating alternative to the original diffusion process. So in the original diffusion process, as Moana told you, everything happens in steps. I want you to imagine this is like flipping pixels. The model is flipping pixels over and over to achieve some sort of image in the end. But this is quite tedious and also inefficient. So what researchers thought about is using, like, they want to make it more efficient. So they are using some techniques from optimal transport theory. And what exactly this is like, it's called flow matching. And what this does, it tries to find a path between a random noise distribution, as you can see on the right-hand side, and a target distribution, as on the left-hand side. This is essentially the image we want to create. And these distributions can be connected through paths or through a flow. That's why it's called flow matching, right? And I have this very nice visualization. I found this very helpful. On the left-hand side, you can see the noise is actually doing this like chaotic steps to get to some sort of target distribution. But what we want to achieve and what is more efficient is actually drawing direct lines between the random noise and the target distribution. Maybe also an analogy on this is using GPS instead of just using, for example, markers. If you would try to find your way through a forest or whatever, you could use markers and trees and whatever, but the best would be if you would just know what direction to go into and what velocity to use. And this is actually what the model learns here. So this is based on optimal transport theory, as I said, and it's not only more efficient, but it also provides more stable training, and it's inversible. So its invertibility is actually a characteristic that is quite nice because you can then also use it for in-painting, like reversing generated images and in-paint stuff, or just edit those. Oh, actually, I wanted to tell you a bit about like some machine learning gossip on this. So Patrick Esser and Robin Rombach are the authors of a paper that was released in 2024. This year's April. It's called Scaling Rectified Flow Transformers. Actually, that was the name. And they, at this point, were both working at Stability AI, which is the company behind Stable Diffusion. And they both went on to found their own company, Black Forest Labs, which is the company behind Flux, also a huge model in use by many. And I just found this interesting. This was the first paper that actually used this flow matching technique in a large scale. And through their switch to their own company, now two companies use this architecture for sure in their modeling processes. And lastly, on this list, I want to quickly talk about the deep compression autoencoder. The autoencoder is, I mean, a bit of an unsung hero when it comes to diffusion modeling, because it is actually able to compress images down to a much smaller size, so diffusion models can actually work with them. So if you, for example, had an image that's like 1,000 times 1,000 pixels, that's 1 million pixels, a diffusion model would like burst from the load of it. But if you compress it down like to an original 8 times smaller size, the model can work with it much better. And NVIDIA actually was able to introduced this deep compression autoencoder, which manages a 32 times data reduction, which is crazy. Now you can not only use like generate smaller images faster, but you can also do more high resolution images. Okay, so that's it from like architecture milestones I wanted to talk about, but I also thought about maybe something that happened in the last 2 weeks. As I said, it's a very quickly moving field, so I found it, I think it would be nice to just tell you what's happened over the last 2 weeks even. So first of all, how I control this images, diffusion models have a problem with control. I've already said this, but they also have a control with instance control, problem with instance control in particular. And what this means is if I give a prompt with 3 different instances, one dog, one cat, another dog, and they all have different fur, then a diffusion model without instance control will have a problem with discriminatory power here. And with instance control, this is like some adaptation that was released 2 weeks back. This is actually improved. And then also GenAI models in all domains, LLMs, but also diffusion models, have a problem with reasoning. I think you all know this. And in the diffusion or computer vision area, NLI is a benchmark that is used to assess such reasoning capabilities in image generation models. And I also wanted to point out this Lava 01 model, which is a computer vision model, but not a GenAI model. I want to emphasize, but its capabilities could easily be converted to GenAI models. Also, because this is like an opinion, at least at last, the diffusion process has a much bigger potential when it comes to reasoning, because it doesn't generate step by step like 1 pixel by 1 pixel, as Moana told you before, but rather it generates everything at once. And so maybe it has the potential to actually be helpful also for language models. So there's also masked diffusion language modeling going on right now and research on that. And lastly, Magic Quill. This is an in-painting tool that's actually using this flow matching process that I told you before. Okay, so before I hand over to Moana, I want to talk about this model in particular. It's a very small-sized diffusion model implemented or released by NVIDIA I think 2 months back, something like this. It's 0.6 or 1.6 billion parameters, very complex. You can deploy it on your own laptop GPU, essentially. And I was asking, how did they actually manage such low generation latency while being on par quality-wise with models like Flux and Stable Diffusion? And what they did is they actually used this DCAE that I mentioned before, and they also used something called linear DIT, which is now basically an opposition to the quadratic DIT that is normally used in such processes. Oh, thanks. Sorry. And you don't have to get like the maths behind this. It's essentially just a little less accurate. I would never recommend using linear transformers for example, for language modeling, but it only has little quality loss for this diffusion model. Also, it uses a small decoder, only LLM, I think it's Gamma, small Gamma model. And this is in opposition to what was used until now, T5 and CLIP prompting. So generally, by the way, NVIDIA is known to data scientists to be great for matrix multiplication and all that, but they are obviously still a graphics company, so they are deep into everything that's happening here. So let's go back to Moana.
So now deployment. If you want to deploy now generative AI for image or diffusion model, you have mainly 2 options. One is using managed model from many providers. You can see like OpenAI and some Azure and Google. You can just use managed model there, or you can host your own model. which one to decide. You have set of questions you need to answer and create the decision matrix, and then based on it, you can select your own model or a managed model. One of those questions first is like the setup time. How much time do you have? Do you want something fast, or you want to spend like 1 year to set up the stuff? So if you want something fast, it's better to go to the managed model. You have an API, you integrate with your solution, and you get the image, for example, direct. But if you do it to host it yourself, you need to host a server, maybe on-prem, or maybe on the cloud, but still, you need to set up all the stuff yourself. You need to host the model, and so on. The scalability, this is also like, if you have high scalability, usually it's managed automatically by the provider. Not always the case, like you can see now with the OpenAI. Sometimes you request 5 times and then it's out, go timeout. But now they're still improving that. But if you will host it yourself, then you might need to buy another server or you host another VM. Regarding the customization, I mean, if first you need to check if the managed model doesn't satisfy your needs, doesn't work with your data, then you need to tune it by your own data, and you need to tune the model. Then you have to host it by yourself because the managed model doesn't support that. They support it, but not really. In the end, it's kind of hosting it by yourself. Regarding the costs, so if you don't have high usage, it doesn't make sense to create the infrastructure yourself. Because if you, for example, you have 500 people or 600 people using your API, it doesn't make sense to buy a server which costs 200K and so. So it's better to go to managed model. But if you have a high demand and high usage, so for the longer time, it's cheaper to host the model yourself. The other part is the experience. Is there somebody has expertise to deploy the stuff in your team or not? If you, for the managed model, you need a low experience, but for the hosting it yourself, you need somebody with high experience, especially tuning the model, using the most of the GPU and so on. And the most important is the data privacy. Many companies, the data is very, very important. And for managed model, you need to check the provider, what they will do with your data. And this is a big issue here. Some of them, they will tell you will not use your data. Some of them, they will say, we will just tune our model with your data. And of course, some example like OpenAI and Azure OpenAI, they are managed model. And the other like Stable Diffusion, and again, you can download them and host them yourself. Now, if you want to host the model yourself, then also you need to decide which GPU I need to buy. If you have so much money, you go to the most advanced GPU, then all your problem is solved. All the model you can be hosted. But if you are a little bit limited with budget, then you need to check how many parameters the model has, how big is the model, and based on that, you can decide, okay, which GPU I need to buy. But it's better always to get a little bit bigger GPU because every day a new model is coming and maybe the more parameters, so it's better to be ready. Also, some tips for the deployment. I will always find it better, especially when requesting image, it takes some time. So it's better to use some kind of event-based solution or messaging solution where you request, do the process, and when it's done, it will notify you back. So you don't have the REST API solution. If you will use the REST API, then it's better to set up the timeout to longer time, because it might take some time, and if you don't set it out for a longer time, it might break every time you request a new image. Another one also, like if you are working on a specific domain and always you have a similar pattern for the image, it's better to store the seed that you are using to generate the image, or caching. So every time you are using the same topic, it will generate the image faster. And also depends the machine size. You need to plan your different patching strategy and queue management, because for bigger machine, you need, for example, different patching compared to the smaller one. And finally, if you have low compute power, it's recommended to use quantization. It might reduce the performance, but it will be a lot of faster. Now going to the small demo that.
Yeah, I've prepared a small video on the Sana usage actually, because I wanted to show how fast and high quality it actually is. So in this video, I will give a simple prompt and just do some altercation on options. You can, for example, set up how many steps the model should take in its inference process and how closely to the text the output should be like related. Maybe you want to be more creative or something like that. And you can also set some sort of guideline, as I told you before, through a control net. So I set it to photographic because this is also used for most benchmarks, by the way. And this, mind you, is running on a 3090 GTX. So it's not running on an industrial GPU, but rather one that you can buy for your own home. I mean, maybe spend 2,000 euros on a GPU. Why not? All right, and that's it from Muhammad and my side. We see. I can actually get, yeah, okay, so some references if you want to read through them. And we also got some questions for you, and maybe some questions we want to take from you and try to answer them as faithfully as possible. Thank you for listening. Comment.
Comments.
Or answers.
That's a good starting point. So we don't have a blank page.
This comparison hosted by the provider versus self-hosting. One key element was that if you scale high, it's going to cost you more on the already managed service. Yet, most of the people are doing that. So, do you have any comment on that? Because, like, you want, as a company, you want to scale. So you want to go have as many usage and as many customers as possible. So, how does this?
I mean, again, like first, I will go with the managed API or managed model because it's low risky and everything already managed. And then if it starts to not fit my need, then I will switch to my own. And here you need to plan, of course. If one server, maybe one GPU is enough, but maybe you need to have multi GPU or maybe server full of GPU. So again, also how much the customer can wait. They need the answer in real time or not. All these parameters you need to calculate to see. Does it make sense for you financially? Because if you can buy a server with 300K, but it doesn't make you earn, like, for example, 10K and so on. So it doesn't make sense to buy a server. So you need to make all these calculations to find the best solution for you. But first, especially with the proof of concept, I will go with the managed model. See if it doesn't satisfy the requirement that they have, then I need to tune the model. Also, I can, for example, use the cloud and buy or buy a VM machine, like virtual machine, and whenever I need another one, then I can add another virtual machine. So I don't need to have that server internally or on the server. This is also another solution. Yeah. You showed the model for image inpainting.
Yeah, I mean, for inpainting, for example, like I would recommend just trying this magic quill that I told you before. And they also got some demos on Hugging Face, as most of those models do. And other than that, I don't have a specific recommendation for this. It actually works with any random mask. I tried to paint. I sent one other example where I painted I'm not good at drawing, so I just painted a stick man on the floor, which should then generate some sort of person that's laying there, and it took this as input. So this is. Yeah, that should work. So basically, the first step is using the segment, then using the segment as input, and then describing whatever you want to in Paint. I mean, improvements are happening as we speak. So in 1 year, you might not be able to tell those apart anymore. Right now, we still have a problem with some. I mean, not all data has been used yet for diffusion model training, and just with more data and more upscaling, we will have more realistic generations. But not everyone wants to also generate something realistic. They just want to generate something that is like resembles whatever we like.
How it is generated, but I have difficulty with some of the human faces. Okay. Okay, yeah, I've heard this comment. It's like it's Photoshop and the skins and everything, because all of the photos which are given are like pure, like that was the training problem. So if you give a lot of noise and real photos, which usually people don't like to contribute, most of the photos they trained on were magazine photos. So that's the reason all the skins are also. I think if you give the feedback input properly, probably you might get some also. The trained model or forums to train perfectly. Yeah, I guess so. But I can also understand the model is perfectionist. So if you take the best out of all, so it might ignore the noise to some level. But I think these are some hyperparameters we probably would be able to human actually. Like we can have a model on defect detection on any skin anomalies or whatever, and then try to enforce it with a high rate on those to be generated. Maybe this would be a shortcut.
But I've got to say that Flux is actually producing such realistic images. I should have brought an example where you should have picked like the one that's actually not AI generated, but this is for next time. Of course.
This is one of the main reasons they don't have this till now, the video generating online, because they are trying to filter it out from the those actual contracts and so on.
I think there is a big topic. We have a lot of colleagues here working on which responsible AI. It's a big core focus of Brian to make sure ethics and responsible AI is covered. So when we are generating material, if we don't have bias for the specific, so as you said, the type of the training data we put in, and also if it cannot be misused in the wrong hand. We had some audio cloning example. But I recall that the audio cloning is also, I think it has a bigger immediate danger compared to video, because usually the more complex thing, we have a longer time to reach there. So first we start with text. That's the reason we see the hype of LLM and large languages, because it's faster to train and get the result. But next one is audio, and then you will see vision and images too. Currently, we are images, but video are also starting, but they're not as good. But people still assume that video generation will happen. But with audio, I recall there was a company when we were doing audio generation. You have a sentence on some cloud providers. You have to say, "I will provide permission to use my audio for these purposes." And when you're saying, you're first giving your voice as a cross check and also reading the exact text. So only if you read that text loudly, the AI has the permission to use it. So nobody can train an AI model on that. But of course, there are many people who are having access to those models, and they may be able to generate such kind of voice cloning, and I think it would be very dangerous. But luckily, there are a lot of work also going on detection of fake, not fake, but AI-generated BS and natural ones. There are many techniques to distinguish them. Of course, Brian is focusing a lot on this direction. At least I know our colleagues are working on this topic, but it's very difficult to control. There is a big danger.
Just adding more comparison of market and actually what market and better down very, very high. Okay. So that's a real danger. And more noise on the source side.
No.
No, but I think if you use GAN, the one we presented before, if you want to clone your model, it can try to learn this. So you have, as I said, you have the generator and the discriminator, and the discriminator try to say if it's real or not real. So you can make a model that just distinguishes real and real, try also to improve it and generate better image. Yeah.
I mean, you can use the generated image as input for your next step, right?
Yeah, that's I think what she meant. So for the next step, you generate non-photorealistic, and you can add post-processing, like adding some anomalies or some unnatural things to the image to make it. Yeah, but the problem is that we actually most of our projects are client-based, so they have to ask the specific requests, and most of the needs we have in the GenAI is to hear a very advertising, marketing material. So they don't like it currently. We didn't have any requests. So we had a lot of opportunities on generating GenAI for retail, marketing material, and they want to have kind of perfect results.
So Francesca is already getting time trouble, I see. So
no, I don't know if I have a questions also from the people in remote. No, we don't.
no question.
No questions. There was a question over where he's waiting.
I was just wondering, I know until recently.
With?
Hands and text.
Oh, with hands and text, yeah.
Solved down.
I mean, solve with more steps and with the flow matching process, for example, the text is generated much better nowadays. And with the hands, this is also like it's not solved, but we're getting better at it.
I'm great, I guess.
Well, as Said mentioned now, is more marketing material generating, like mostly for marketing. Yeah, mostly image. Yeah.
Anything from the
The TV or this, they had another one. They wanted to annotate. They have a set of image and they want to know what is inside the image more than generating the image.
For indexing and searching
So
and finding
indexing and searching.
but I don't think video generation is advanced enough to and the computationally also quite expensive and not realistic. But we had bases of GenAI for in-painting, or we don't have permission from actors. Some of those actors, the movies made, so the permission somehow was revoked, or there were legal complications. We have to all find all those actors and in-paint, anonymize through, or hide faces. Correspond.
You're using this managed
models, or are you training your own model?
It's a combination. We have all types. Sometimes, as Mohammed mentioned, very often you go first the fastest approach using existing solution if they exist, unless you have other concerns, like if the permission or by client, you cannot put that data. Because, for example, movie producer, it's a big hassle to get access to those movies. You have to sign multiple NDAs to get access to. I'm not sure if they're very happy to have those movies on the cloud for fraud. So you have to sometimes develop your own solution to be able to analyze them, find faces, find items or remove them. And also it's very difficult to generate the same quality. You shouldn't lose any quality or information for movies at the end they come out.
You consult on
Yeah.
Your last small question. No, sorry.
Given the high upfront cost of these H100 or higher parts, how often do clients would buy the parts after physically really have to be control?
I think mostly they don't buy, they get the machine from the cloud provider, because if you want to buy it, you need to put it, you need a server room, you need the air condition and so on, all this, and it's alone. And for example, server one is not enough, you need also replicate, because if this one is damaged, you need some.
So we still trust when data someone else.
This is why, so when you are a cloud, you usually define the region. Like if it's, for example, this cloud, these servers are in Europe and they are follow the Europe rules. So you know that the data will not be transferred, and it's on your own data. They don't have access your data. This is if you have the VM or virtual machine already in the cloud. If you use the managed model, this is another story that you don't know what they will use with the data.
And a similar question. So you said that you're generating images from magazines, right?
But yeah.
How do you get the data to train the model?
They give us the data.
They give you the data,
yeah. And also sometimes, like for example, DALI, it has already some trained data, so it can generate something quite nice. So the idea, like we need to do prompt engineer, write the best description to get the best output. Yeah.
But given that some people are suing because image libraries were crawled but without permission, you run into any copyright issues when you reuse?
I mean, if you are using the managed model, then we don't have any. But our problems, the provider, so we don't have any issue there ourselves, because we are using managed model and it's their own responsibility. We didn't use any data from somewhere else.
And the marketing material were not at the exact examples were not about retail material, but clothing and other that critical that they are faced. So I don't think they generate.
I mean, like a paint, like some art or painting, maybe.
More questions? Yes, please.
Follow on for this again.
Again,
I think what you're asking is how to make sure that your one vendor doesn't lock us there, and then the client has the flexibility if they want to tomorrow bring it on-prem or go to other providers, they have this flexibility. Is what you're It's usually we are vendor agnostic. We don't choose the vendor. So we are best partner with Microsoft. We have a very multiple partnership award with AWS. We have a good cooperation with Google. So we are all vendors cooperating with all of those vendors. So we don't recommend normally, you have to go with that unless if client has a platform that it's their platform of preference. They would say they would like to work. But if the service is already on the platform and you're using those services, so this is something that we have two types of limitation. One is that some of those are services that can be containerized and separately used with some license agreement. You're paying per user or whatever. Then it's kind of locked, and you can even have it on your prem. So there are some services that different cloud provide. If they're smaller and packageable, you can Docker it and run it on your platform on-prem even, and then you just get billing information of how many usage you have. Some others are not possible. They're more complex and they're very secretive, so they only give you permission. Those ones, unfortunately, you have to rely on them. Like maybe some of those OpenAI or ChatGPT, you don't know what the models are huge and trained on a lot of data. I had similar one with AWS recognition of face recognition. I think it still outperformed with a lot of face recognition. I tried my own face of like 10 years ago from side with a mask, and it could detect, say, 99.9, these two persons are the same. So it was amazing. I still didn't see any other libraries or like other models, that custom models are doing the same performance. Also, I studied multiple comparison of the face recognition and comparison. So some of those cloud providers are doing an amazing job, and it's a black box. We don't get to know what are all the details behind. But how not to get locked is about the agreement at the beginning. You need to understand what are the expectations, what are the limitations, for how long you're gonna work there, if it's just testing, and if they want at some point, we can develop AI models for themselves. We have many clients that are not really starting from beginning to get locked there. They do only a POC. It's visible, proof of concept, prototype, or solution validation. Okay, it is possible. Now let's develop our own solution independently. Yeah, that is one of the expertise of our college.
Yeah, that's why, but this is considered as something you do yourself. So in this case, you need to manage that Kubernetes. You need to manage pay for the servers that you are consuming and so on. So again, you need to make a decision here. Is your data very sensitive? Is the managed model is giving good result or not, and so on. Based on that, you need to make a decision what to do.
For text models, in some cases, these model routers, there's one API running hundreds of different models behind that. Something like well-established for the vision part as well.
I mean, in the end, it's possible because you can have it's APIs. You have API for the stable diffusion, API for example, OpenAI, and so on, and you can just have another API which control all this, and then you can select which image I want to generate. So it should be just possible.
Also would make sense if you say, I don't need the highest quality image, for example, then you could just route to a smaller model. That's like not as expensive to host.
I will close the discussion, but you can continue maybe later or so.
Yeah.
All right.
Thank you.
Thank you.
So, our next speakers will be me. Tonight they're gonna hear me a lot talking. It will be mainly my colleague Philip.
That's not me. Sorry.
Okay. So Philip is a PhD student at Technical University of Vienna. He has a background in machine learning, sorry, mechanical engineering, and he's worked at the Energy Economic Group in heat pump flexibility. Yes, in residential buildings. So, yeah. Well,
You have to move.
Yeah, sorry. I was not seeing that. No, right?
Yeah, I know, but it's
we are coordinating.
Spiegelverkehrt. Right?
Almost. Yeah. Yes, we made it. So we jumped from a generation of images to generation of synthetic data, of energy data, really nice connection because already some problems like getting the data, using the data, gonna help us to introduce our presentation, our project. I will briefly introduce the project and then I will give the floor to Philip. Sorry about me. I work in a spin-off. I'm a researcher working a spin-off from Technical University of Vienna, focus on building energy efficiency and energy modeling. So tonight we are going to present one project that we are working on. It's called Moderate project. Is a European funded project. So we switch also from production to developing actually the product. So we are going to present what is about the project, bit of synthetic data, and then Philip will dive into the GAN architecture that he used to generate the synthetic data, and we have also open questions. So the Moderate project, as I said, is a EU-funded project. Is running over 5 years. And the main goal of the project is to create an open access marketplace where in the energy and building sector to access data and tools to analyze data for building decarbonization. Is under the umbrella of decarbonizing Europe, and is getting a lot of attention because it's going to be actually open access and available to stakeholders, companies, and research centers that are focused in this sector. So the second goal is to match data providers, actually specifically energy providers with consumers, with stakeholders, that they have the tools but they don't have the data, or also on the other way around, with energy providers that have the data but they don't have the tools to fish out information, meaningful information from their data. And it's always about sharing data and service, because it's a European project funded by public money, so by taxes actually. So this is something important. It's an important value. The outcome of the project will end next year, will be to have a platform with data sets with synthetic data. So we cannot provide for GDPR reasons the real data. Tool set to analyze the data, like to analyze photovoltaic, where to install photovoltaic panels, to analyze smart meter data, to make houses energy efficient. And the goal is to have this marketplace of exchange between data providers and stakeholders. So who is working with synthetic data? No one. Okay, I see some hands up. So why are so important? So actually, I think you're working because either you don't have enough data, so you want to do some data augmentation, or because you don't have access to the data, or you cannot use and share the data. Actually, you cannot share the data, like our case, or also because you have bad data. So usually these are the reason why people they opt to use it to create a synthetic data and use them instead of a real. The advantages are privacy and confidentiality is preserved, with scalability and annotated data, but also it comes with some downsides or challenges. First, the quality is not always high. It depends a lot on the algorithm, how it's tuned, to the parameters, the computer resources we are experiencing. We are working at TU Wien, so we are experiencing, for example, some limitation with computer resources because you need a GPU to train the models and also control over the algorithm. Sometimes it's a black box. You don't know what, you know what gets in, what goes in, you don't know what comes out. So in this project, in the project that we work, we use synthetic data mainly on 4 types of data. APC data are the energy performance certificates, load profiles, mainly electricity profiles, so time series, heating profiles, and we have sensor data. So I hand over the floor to you.
Yes, thanks, Francesca. And yes, as Francesca said, my background is mechanical engineering, and I focus on heat pump flexibility. So when I got this task of generating synthetic smart meter data, I thought, you already have this amazing image recognition. How hard can it be? You take some GitHub repository, put the profile as a heat map inside of one of these image generators, and generate fake profiles. Turned out it was not that easy, at least not for me. Also, we didn't have a lot of training data, which is basically the main problem we also want to address. Energy providers, they don't give out their data because even a profile itself contains, even if it's anonymized, you don't know where it is, the profile shape itself can contain personal information, according to lawyers. And that creates problems because these companies, especially small energy providers, we have one in the project, they cannot do big, they cannot use their data, or they cannot sell their data to get it analyzed, to get some insights. So what they want to do is they want to synthesize it. We know from big energy providers, like the biggest one in France, they already do this, but algorithms are not out there. And I think in the energy sector, when it comes to synthetic data, we're like 5 years behind when compared to what's happening in large language models or in image generation. We used a GAN. It was already introduced by former speakers. We have one generator that tries to create an image, and the discriminator that says this is fake and real, and they train each other. And now I'm gonna show you what we exactly did. It's very simple compared to these diffusion models. We didn't opt for diffusion models because of the computational intensity. We only have one of these small GPUs that you presented at our server. The battery is running low. Do we have a charger? Thanks. So I'm gonna present to you. The architecture that we used, that we came up with, the discriminator, basically we put the
it's still recording. Nope.
Yeah. This is off time. But the FN doesn't work. Yeah. Okay. So we rearrange the profiles into 368 days times 24-hour shapes, basically. And then we throw them through a bunch of convolutional 2D layers with varying kernel sizes in the discriminator. And then, you get an output. It says yes or no, 0, 1. And we have the basically same architecture, just turned around for the generator, which is unusual, I think, at least what I saw in literature. Usually the discriminator is a little bit weaker, smaller, because identifying if something is real or fake is an easier task than generating a profile out of noise. A noise vector goes into this into the generator, and then again we have convolutional transposed layers this time to generate 368 days times 24 hours of load profiles. I don't know if I should go too much into the details of the layers, batch norm and dropout layers. In the generator, in the discriminator, we only had one batch norm, but no dropout because it worked better. And for the training, we use different learning rates. The discriminator has a lower learning rate than the generator. And because the generator and the discriminator have the same size, we train the generator 3 times more. So every epoch is trained 3 times, the discriminator only once, to keep the balance between those two. Otherwise, the discriminator gets too strong too fast and always knows that the generator is producing fake profiles and the generator doesn't learn. A loss function was binary cross entropy. And then let's come we come to the data. We use an open source data set here for the presentation. We with 1,300 smart meter profiles. There's not many data sets out there that have more than 3,000 profiles, which is already not a lot, in my opinion, for training generative AI models. This data set is unique in a way that it has labels for the data. So we have profiles from households that have an EV with a PV, nothing at all, or with a PV installation alone, or with a PV and a heat pump, which makes the whole thing, for us at least, a little bit more interesting. Here's the losses and for the training of 1,000 epochs, and we see here that in the beginning the generator goes up, then it comes down, and then it more or less stays. This model doesn't seem to learn a lot anymore. I wanted to show you this because maybe some of you are machine learning experts and know how we can do this better. Also, when to decide to stop training. If we keep training, at some point, either the generator or the discriminator loss will skyrocket because one of them outperforms the other. Here, we usually stop at around 400, 500 epochs by looking at generated profiles and saying they look good from the statistics. Like, for example, this, we look at the frequency of the frequency distribution of the data. If they look similar, real and synthetic, then we check if the mean consumption or the mean load profiles align. They do so relatively well. We see stronger differences in the households that have EVs. Apparently, when we see higher single peaks, this is difficult for the model to grasp. And here, the max or the maximum peaks of the whole year are really a problem right now. As for the houses with PVs, we see that our model generates always higher peaks in every case, but it's most pronounced in the households that have high peaks already. And we haven't figured out how to fix this problem. But for the rest of the statistics, it looks relatively good. In literature, it's often shown like the 1-day mean profile, synthetic real, that the generation worked well. We see, I plotted this as well here. We see in dotted lines is the synthetic profiles, and in the whole line is the real profile. And you can see that the PV households have the stack curve, so the demand during the day goes low because they have PV generation. And for the EVs, you see higher peaks in the evening when people come home and charge the EV, or with the heat pump because people are at home and start heating or showering if they generate hot water. What we also see is that for some of the profiles we get the shape really well. We can the synthetic data can grasp the shape, or the model can follow the shape, but also the mean is a little bit off in some cases. But we also don't want to be too perfect because then we get legal problems again. So open questions for us are, how do we determine if personal information can be inferred from the synthetic data? We actually still, now we took out any personal information. We have just load profiles. From the real profiles, we already thought, no, you cannot know anything about the owner of this profile. But then we looked into the profiles and we actually could identify nightclubs, for example, in the small city, because consumption is high at night and nothing else. So you can infer personal information. What you do with it is another question. But how do we? This is actually a question that the legal offices ask us: can we, if we synthesize now the data, can we just throw it out there? Is this safe? How do you determine how good the synthetic data is? Just based on the statistics, you can look at it, but I think it depends on the use case, what you want to use it for. How to implement a reliable early stopping for this training with this oscillating losses, and how can we fine-tune the GAN to be more accurate for this peak demand prediction. Our code is online if anyone is interested. And that was it. Thank you for your attention.
If you open the floor for discussion
Or feedback.
Just to say, the problem we're facing with personal information by law, by GDPR law, the electrical load profiles, so electricity consumption is protected by GDPR because it's possible to trace the user's behavior when they are at home. Many people.
I have a question to the second question. To say, how do you actually determine goodness? What is a higher level thinking about what goodness is? How well it depicts the real data, or how well it protects the identity of those who don't want to, figure out. So.
I mean, I was hoping that you have an answer.
Actually, just yesterday we had a talk with some colleagues from Italy, but they developed a package. Oh, sorry. To check that it's not possible to trace any personal information from synthetic data.
But tabular data.
But now it's for the moment it's only for tabular data. We're going to implement it for time series data. It's something that we want to address in the validation process.
I feel like still I don't believe like each person has his own way of consuming electricity and it's unique, isn't it? I mean, maybe it will be extra protection because like
It's
company maybe they consume the same, but I cannot say it's you that based on the consumption, it's you. Of course, if you collect just 4 people, and it's just 4 people, it's easy to distinguish the people. But if you have so much data, then it will be very hard to distinguish. Oh, this is consuming.
That's That's what I would argue as well.
What we argue as well, but
course,
legal office.
Whom did you ask for this?
So
For energy providers, they won't give us. Yeah, but
they are conservative by definition.
of course, yeah.
The lawyers of the energy
providers.
providers are ultra conservative. If you go, for example, Nicolas Borgo, he is the head of the Institute of Legal Tech and Innovation at the University of Vienna. He has a different opinion. What you can do with GDPR, especially when you do scientific research. So,
Because here is
don't want to open a big discussion. There's a lot of space in argumentation in that area.
yeah, for example, we receive some energy data from an energy provider, just a small one, and the legal office raise questions that if we should have or not the data because they can be charged at 10% of the revenue. This is a core problem. So they had to collect the data. So at the end, they gave us the data from the users were people from a company. And actually, we were not even able to guess if the users were residential or no or commercials. But still, they raised the point. It's like this 10% of the revenue. They are really.
Do you have an answer to this question where you said you can identify that it is a nightclub, for example, but as long as you don't identify which nightclub it is and where, is that okay or it's not?
Well, the thing is, this energy provider is small, so if you know the region, you know. I also, what do you do with this? You can go on Google and you see the opening hours. You have more information about the nightclub and images and whatever.
Yeah, it's a discussion about the competition in the market.
I don't know.
This is what I've been to discuss. We are also in contact with the e-control about the legal aspect.
There was a question.
Yeah, I was just wondering this idea that like the energy consumption is firstly identifiable information. Can't you also measure this from infrared emissions from the house, which is still from the public street?
Satellite images with infrared are, as far as I know, not that accurate. Like you need a very high resolution, and then also the building thermodynamics is very slow, and especially in multifamily buildings, it's just
Are aggregated.
But you could maybe infer the EPC status or the insulation status, but not really inhabitant behavior. If you want to run around with an infrared camera, I think it's cheaper if you just put a camera and film the people around. You go through the walls.
Yeah. In which case you have new problems, right? I mean, the idea that data generated may have some anomalies that could over time be quantized into specific functions is really dangerous. You can identify hospitals. It's also going into that area. So that is why it's a 10% or 20 million or 2% of the annual cost. You can.
Just question, you try to use another way, like learning the distribution of the data and then try to.
I tried variation in autoencoder, but I have to admit the time was limited, and then we already started with the GAN. I had a mode collapse, or it just learned the mean. There was no variability in the. We just went with the GAN, even though we also had trouble.
You concentrate on the two. What is the actual use case? Is this for modeling or solar panel?
I mean, for us, the use case would actually to generate data that could be used for scientific purpose. For example, houses with typical load profiles for houses with PV installation. They're not a synthetic single profile for modeling, for example. Or another partner developed an HVAC identification from smart meter to be able to train such a tool.
Sometimes the mathematics is enough to actually estimate better.
By taking the real profiles and just
create something. Sometimes the information it wouldn't be, of course, as detailed. That particular use case.
Use case dependent. We played. Yes. We used the Wasserstein gun. We tried to condition the gun on and only generate daily profiles and condition them on weekday, weekend, workday, and the month, for example. Then we wanted to generate whole year profiles because in literature most people do it. They split it up into days, train it on days, and generate day profiles. And we said, no, we want to have yearly profiles and not put them. I don't remember what the Wasserstein gun problem was, or for us, why we didn't go with it. But you mean you just use the metric, right? Yeah. Yeah, it's thank you. Maybe we will take this up. Thanks.
So if no more questions, I will open the. Thank you, Philip. Actually, I will open the floor if you have any announcement. I have an announcement, of course, Anton. So always related to this project. In February, we're gonna have an hackathon on generating synthetic data for the building sector and also trustworthy AI. Is already online and we organize it. It's going to be, the organizers are the TU Vienna scientific clusters who nicely provide us the use of a supercomputer and the Vienna Data Science Group. If you want to enroll and hack for 2 days, meet nice people, climber, passionates, this is the right place. If any of you is interested in being, we are looking for mentors and for jury members. So if you want to join the community of helping the attendees or evaluating the outcome of their challenges, please approach us or send us an email. Yes, so you can also approach Julia and Martin that are here in the room from the Vienna Scientific Cluster. And if there is no more announcements, maybe online. Let's see. No. It's difficult here too. No. No one from. Okay, so I would stop sharing, stop the record, and Now is the fun part, eating and talking. So thank you so much to Crayon for hosting us, to our speakers to take the time and contribute to the community, and for all of you for coming in the evening also in a really cozy place. Thank you.
Food is coming in about 15. Stick around.
So for the, okay, everyone left.